A robot just did your laundry, not a joke. Figure AI that ran an hour of autonomous package reorientation in a warehouse is now folding towels. Same model, same settings, they only changed the data. And it works. Sounds easy? It's one of the hardest things in robotics. Towels don't hold a shape. They slump. They wrinkle. They stick to themselves. There isn't one right place to grab. One slip and the whole thing bunches up. To win here, a robot needs sharp eyes, quick decisions, and careful fingers moving in sync. Watch what Helix does. It looks at a mixed pile. No neat stacks. It chooses one towel, lifts, and if two come up, it fixes the mistake. Returns the extra. Traces the edge with a thumb. Finds a corner. Pinches, slides. Smooths the surface, then completes the fold. No step-by-step program for every wrinkle. It's end-to-end. Vision and language go in, precise motor control comes out. Here's the big claim. A first for humanoids. A multi-finger robot, on a human-like platform, folding laundry fully autonomously using an end-to-end neural network. No special architecture for cloth. No new training tricks. Just a data swap from logistics to laundry. That means the brain is general. The hands are capable, and the loop between them is tight. Why does cloth beat so many robots? Because object models break. With rigid parts, you can say, this is the box, this is the corner, pick here. With a towel, the object keeps changing as you touch it. Edges hide, corners move. If you pause, gravity makes a new shape. Building a perfect representation is brittle and slow, so Helix skips that. It learns the behavior directly. See, decide, act, adjust mid-move. Try again when it slips. That's how humans do it too. By the way, subscribe now because next week we're posting our top 10 humanoid robots of 2025. You won't want to miss it. Look closer at the behavior. Strategy shifts with the starting state. Flat towel? Go straight to a center fold. Twisted towel? Unravel first. Corner buried? Trace the nearest edge until a corner appears, then regrip. Multi-pick error? Put one back, keep the other, don't restart the whole task. This is the kind of resilience you need for the real world, where nothing stays perfect for more than a second. There's also a human-aware layer. Helix keeps soft eye contact. It aims its gaze where it's working. It uses small, learned hand gestures when it communicates intent, like pausing and framing the towel before the final crease. Those cues matter. People read them without thinking. If robots can produce them naturally, collaboration feels safer and faster. And remember, this is the same architecture that handled boxes for an hour. No code fork, no new hyperparameters, only new data. That's the headline. One model, many jobs. The platform doesn't change either. Same humanoid body, same multi-finger hands. The brain just absorbs a new slice of the world and maps it to the body it already knows. So what does this unlock? Imagine a single learning system moving across domains. Logistics on Monday, assembly on Tuesday, home service on Wednesday. As the real-world dataset grows, the model's dexterity, speed, and generalization grow with it. The reward is compounding. Every new task teaches patterns that help with the next one. Find edges, resolve occlusion, manage slips, plan regrips, keep balance while the hands work. Let's be real about limits. Today, it's towels. Not shirts, not fitted sheets, not a tangled laundry basket with socks stuck inside. Speed isn't human yet. Reliability has to be proven over long shifts, not just clean demos. But the slope here is what matters. They didn't win by adding 1,000 special rules. They won by adding the right data to a general model and letting it practice. This is also a signal for hardware. Multi-finger hands are finally paying off. For years, grippers won in factories because they're simple and strong. But the moment you touch cloth, wire bundles, cables, or bags, fingers matter. You need rolling contact. You need microslides. You need tiny regrips that keep the world stable while you change your plan. Helix shows the software side is catching up to that promise. What do you think? Will this kind of dexterity make humanoids more useful at home? Or is it still too early? Drop your thoughts below. Think about the workflow. A camera sees a pile. The model parses the scene and picks an action. Reach, lift, pause, regrip, smooth, fold. The feedback loop is fast. If the towel sags, the wrist adjusts. If a corner hides, the thumb searches. If the plan fails, it doesn't panic. It tries a different approach and recovers. That calm, adaptive feel, that's what end-to-end buys you when the world won't hold still. Now zoom out. We just watched a humanoid transfer skills across two very different settings using the same brain. That's the North Star for general-purpose robots. Not a single scripted stunt. A system that can learn from one domain and apply it in another without rebuilding the stack. If they keep pumping in diverse real-world data, we'll see smoother hands, faster loops, and broader coverage. Kitchens, stores, labs, and lines. So here's the question. Did Helix just cross the two-human line for dexterity? Or is this the first small fold on the way to full household competence? Drop your take below, and if you want the raw action, stay for the demo. Watch for the edge trace, the corner pinch, the error recovery, and that final clean crease. If you're into real-world robotics getting useful fast, you'll want to see this one through. Subscribe for the next breakdown. We're tracking every step.